Hackers use various techniques to crack software, typically aiming to bypass protection mechanisms or gain unauthorized access to software and its features. Cracking is typically done with the intent of circumventing software licensing or unlocking features that are typically restricted to paid versions. In this video, we explore some common methods hackers use to crack software and ways to protect against them. Disclaimer: this video is for educational purposes only. It's important to note that software cracking is illegal in most cases as it violates the software license agreement and intellectual property rights. Engaging in software cracking without explicit permissions of the software owners can lead to legal consequences. Let's start with the software cracking techniques, and then we will guide you on how to protect against these techniques. Number 1. Reverse engineering is used to understand how software works, identifying and exploiting vulnerabilities in the software code, and then modifying the code to achieve the desired outcome, such as bypassing license check or unlocking premium features. Hackers compile the software code with debuggers such as SoftICE, OnlyDBG, GDB, or MaxBug until the software cracker reaches the subroutine that contains the primary method of protecting the software. They also could do reverse engineering by disassembling an executable file with a program such as IDA. Number 2. Keygens and cracks. Hackers create key generators or software cracks to bypass licensing mechanisms and activate software illegally. Keygens or key generators operate by exploiting the cryptographic systems used in software activation processes. Fundamentally, a keygen mimics the legitimate software's key generation algorithm to create valid activation code or serial numbers. To achieve this, keygens often employ reverse engineering to dissect the software's binary and understand its license verification mechanisms, which typically relies on cryptographic hash functions or public key cryptography. In detail, the process begins with the keygen decryption or disassembling the executable to locate the portion of code responsible for generating or validating cryptographic keys. The segment of code usually involves an algorithm that generates a serial number based on a seed value or a public key, which then undergoes a hash function like SHA secure hash algorithm or an asymmetric encryption scheme used RSA to produce a unique fixed-size output. The keygen replicates this algorithm to generate serial numbers that the software's activation routines will accept as valid. Once the algorithm is understood, the keygen can implement it independently to produce keys without the need for actual cryptographic secrets held by the software vendor. For example, if the software uses a simple checksum or proprietary hash-based validation, the keygen might reverse engineer this algorithm to produce key values that successfully mimic the checksum accepted by the original software. Number 3. Patching is a term used to address the fixing bug or security issues in software. In software cracking, patching refers to the techniques that hackers modify the software's executable files to remove security checks or restrictions. Hackers bypass the security measures of software applications, allowing unauthorized access and use. A patch typically modifies or replaces executable files to remove or disable key features or software protection, enabling the use of the software without adhering to the licensing terms set by the software developers. Number 4. Pirated copies. Hackers distribute modified versions of software that have been tampered with to remove licensing or protection features. The cracked software might contain harmful arbitrary code. To protection against software cracking, what should we do? Number 1. Code obfuscation. Use code obfuscation techniques to make reverse engineering more challenging by obfuscating the code structure and logic. Number 2. Licensing and activation. Implement strong licensing mechanisms and activation processes to prevent unauthorized access and usage. Number 3. Digital rights management. Utilize DRM solutions to protect software from unauthorized copying and distribution. Number 4. Anti-tamper techniques. Employ anti-tamper mechanisms to detect and prevent modifications to the software. Number 5. Code integrity checks. Implement code integrity checks to verify the authenticity and integrity of the software during runtime. Number 6. Encryption. Encrypt sensitive parts of the code or critical data to prevent unauthorized access. Number 7. Continuous monitoring. Regularly monitor and analyze software for unauthorized modifications or tampering. If you enjoyed this video, don't forget to give it a thumbs up and subscribe to our channel for more security content.